Hi, today we're looking at NCFE Level 2 Functional Skills Maths. This is paper P001441 or the December 2020 past paper. We're going to start with the non-calculator section. Okay, question 1. Jessie is the manager of a shopping centre. She knows that 3/5 of the shops sell clothes, 1/8 of the shops sell electronic goods, and all the other shops sell food. What fraction of the shops sell food? Okay, well, let's think of this in a bit of a table. So if we think, well, we've got clothes, that's 3/5. We got electronic goods, that's 1/8. And all the others sell food. So food is question mark. So we're trying to work out what this is, okay? Well, if we know what these two are, well, then we'll be able to work out what's missing to make up the food. Okay, so let's start off by thinking, well, we said if we add these two together, we know the rest must be food. So that means that what we want to do is 3/5 plus 1/8. Okay, so when we're adding or subtracting fractions, we need the denominators to be the same. If they're not the same, we can't do anything yet. Okay, so they're clearly not. So we say, well, does one of the denominators go into the other? Well, 5 smaller. Does 5 go into 8? Well, not without remainder. So in that case, we need a denominator that both 5 and 8 is going to go into. And a nice, easy way to do it, it's not necessarily the most efficient, but in this case it will be. We can multiply the denominators together. So if we do 5 times 8, we're going to have 8, 16, 24, 32, 40. So what we're saying is we can write these fractions as being out of 40. Because we multiplied them together, we know that 5 goes into 40 and 8 goes into 40. But these need to be equivalent fractions. So in other words, whatever fraction we have here has to be the same value as 3/5, just with different numerator and denominator. Okay, so the way we do that is we say, well, how are we getting, if we think about the denominator, how are we getting from 5 up to 40? Well, we multiplied the 5 and the 8 together to get 40. So we're saying we're multiplying by 8 to get from 5 to 40. Now, if we're doing that to the denominator, to keep the fraction in balance, so the same value, we also need to multiply the numerator by 8. So 3 times 8, we've got 8, 16, 24. So 24 over 40. Okay, so all we've done is rewritten this fraction as an equivalent fraction, but with a denominator of 40. Now, the second fraction here, we know that this can have a denominator of 40, again because we multiplied the 5 times 8 to get here. So we know 8 goes into 40. And how many times does 8 go into 40? Well, 5 times. Okay. If we're multiplying the 8 by 40, then to get the numerator, we need to multiply, we multiply the 8 times 5 to get 40. We need to multiply the numerator by 5. So 1 times 5 is 5. Okay, so 5 over 40 is the same value as 1 over 8. But the difference is that now we've got these both over 40, all we need to do is add our numerators together. So 24 plus 5 is 29. And now because we've got the same denominator, we don't add them together, but we just keep it as it is. Okay, so we've got 29 out of 40 is the total of clothes and electronic shops. We want the missing food shops. Well, if the total we're looking at, the denominator is 40, then what we need is 40 minus the 29. In fact, if we move this up, we can do it as a column subtraction. So we can say 0 take away 9. Well, we can't do that because 9's bigger than 0. So we'll reduce the 4 to a 3 and give our 1 to the 0. So now we've got 10 minus 9, which is 1, and 3 minus 2, which is another 1 to give us 11. So if we had a total of 29 out of 40 for these shops, then that means that the food shops are going to be, oh, that's not a dot, that was just my pen, 11 out of 40, or 11/40ths. Okay, on to part B. Let's move it up here so we can see all the question. Jessie will let this unit in the shopping centre. And we've got this diagram here. She has this information about the floor areas of other available units in the shopping centre. So this is the unit floor area in metres squared. So one's 51.1 metres squared, one's 82.3, and so on. Jessie thinks that the unit she will let, so this one up here, has a floor area 12% larger than the median floor area of other available units. And what we can't see below is she correct? Okay, and we've got 5 marks for this question. So we're going to need to work out the area of this, but we're going to be comparing it against the median of the other units that we've got. So we can, it doesn't really matter which one we do first. Let's do the area first of all, okay? So we've got a shape here, 1, 2, 3, 4, 5 sides. There's not an easy way that we can work out the area of this shape in one go. So what we're going to have to do is split it up into 2 shapes. And what I'm going to do is draw a line across here. So now what we've got is we've got a rectangle up here. And let's just put the area of a rectangle is the length times the width. So we can say the area of this is 12 times the width, which is 2. And if we do 12 times 2 over here, 2 times 2 is 4, 1 times 2 is 2. So this top rectangle is 24 metres squared. Now this shape down here, well, what's this? Well, it's got 1, 2, 3, 4 sides, and we've got 1 pair of parallel sides. So this is a trapezium. And if we want to work out the area of a trapezium, there's another formula, which is half times A plus B, where A and B are the parallel sides, and then we multiply it by the height, where the height is that height there. Right, so we said it's going to be a half times, well, A plus B, well, we know this is 12 metres across, and B, the bottom, is 8. And the height, well, we know that all of this is 7 metres. This top bit here is 2 metres. So 7 minus 2 gives us that this must be 5 metres. Okay, right, so let's do this a bit at a time. So we'll keep the half. Let's do the bit in the brackets first. 12 plus 8 is 20. Okay, if you need to do it as a column, that's absolutely fine. Then we multiply it by 5. Well, half times 20, or half of 20, well, a half of 2 is 1. And then put the 0. So we want 10 times 5. So we can do 1 times 5 and add the 0. So we've got 50 metres squared. Okay, so that means that our total area is going to be 24 plus 50. 4 plus 0 is 4. 2 plus 5 is 7. So it's 74 metres squared. Okay, right, so we've got our area. Now we've got to compare it to, what was it, the median floor area of the other available units. So if we want the median, we want to know what the middle value is. So really we need to rank them in order. So what's the smallest value we've got? 49, anything small? 40, so that's the smallest. So 1. Then this was the second smallest. They're both in the 40s. We've got this in these two in the 50s, so that's the next smallest. Then this one, anything in the 60s. We've got one here, so that's going to be 5th smallest, 6th smallest. Anything, only one in the 70s, one in the 80s, and one in the 90s. Okay, so let's put them in order. In fact, let's write them up above. So the smallest was 40.7. The next one was 49.8. Then we had 51.1. Then we had 59.4. Then we've got 67.6. Then the next one, 68.9. 71.2. Next one's 82.3, and finally 90.2. So to find the median, we cross off the smallest and largest, next smallest, next largest. Keep going in pairs until we end up, well, because we've got an odd number of values here, we're going to have one value in the middle. Okay, so we can say median is 67.6 meters squared. Okay, so Jessie thinks that the unit she will let has a floor area 12% larger than the median. So we want 12% larger than 67.6. Okay, well, if we work out what 12% is, we can then add it on to find our answer. So we haven't got a calculator here. We could do 12 over 100 times 67.6. That feels like it's going to be quite messy. So I'm going to start off by saying, well, what would 10% of 67.6 be? Well, if it's 10%, if it was a whole number with a 0, we'd take the 0 off. But if we want to make it 10%, we move the decimal point over 1. So it's going to be 6.76. Okay. Now we want to get up to 12%. Well, we've got 10%. We could add on 1% and 1%. That would give us 12. So let's move this up. Well, if 10% is 6.76, 1%, 67.6, we just need to move that decimal point along one more. So if we're moving it to over here, it's going to be 0.676. And because we want 12%, we said, well, we want another 1%. Which is going to give us, I should have lined this up better, 0.676. Okay. So we need the total of all of these, so I'm going to add these all together. So I tried to line them up, so we should have all our units in line. Decimal places are slightly out of sync. But I put the 0 in here, so we can see that we've got nothing to add on to these 6's. So we've got 6 plus 6 is 12, plus 0 is nothing, or still 12. Then we've got 6 plus 7 is 13. Add another 7 is 20. Add 1 is 21. 1 and carry the 2. Now we've got 7 plus 6 is 13. Add this 6 is 19. Add this 2 is 21. So put the 1, bring down the decimal place, and carry over the 2. Now in terms of the whole numbers, we've got 6 plus 0 plus 0 plus 2. So we've got 8.112. Okay, now that's the 12%. So we want to add 8.112 onto our original 67.6. And as before, I'm going to put a couple of zeros in here to see we've got nothing to add to these. So 0 plus 2 is 2. 0 plus 1 is 1. 6 plus 1 is 7. 7 plus 8 is 15. 6 plus 1 is 7. So we've got a total of 75.712. Jessie thinks that the unit she'll let has a floor area 12% larger than the median. Well, we've got 74%. Well, no, that's less. Let's just put it down here. Than the 75.712. So this is what she's got. This is what 12% larger would be. So is she correct? No. She's incorrect. So it's up to you if you want to work out the median first or the area first, but ultimately what we need to do is increase 1 by 12% and then compare the two values. Okay, question 1C. Jessie lets a unit with a floor area of 40 metres squared for 12 months. The unit costs £27.59 per metre squared per month. What's the total cost of letting this unit for 12 months? Okay, so what we can do, if we work it out how much it costs for 1 month, well, what that would be is £27.59 per metre squared. So that's going to be multiplying it by 40. But what I'm going to do is ignore the 0 for now. Just multiply it by the 4. Okay. In fact, we can even ignore the decimal point. Okay. Let's forget about that. So we just got 2759 times 4. Okay. We'll put the other bits in afterwards. So 4 times 9. 9, 18, 27, 36. 6, carry the 3. 4 times 5. 5, 10, 15, 20. Add on the 3. 23. 4 times 7. 7, 14, 21, 28. 29, 30 because of the 2. 2 times 4 is 8. Add the 3. 11. Right, this is where we now add everything back on. So what we can say is, well, we did it times 4, but we wanted times 40. So we put an extra 0 on the end. And then we ignored the decimal place, so we actually had 2 decimal places, so we need to put the decimal point back in 2. Okay. So we have got a total of £1,103.60, and that's per month. Okay. Right. For 40 metres squared. So we had it for 1 metre squared, now we've got it for 40 metres squared. So what do we need to do with this? Well, if this is for 1 month, we then need to multiply that by 12. Now, what we can do something similar to before, and we can say we got 1103.6. In fact, what we can do with this one, I should have ignored the decimal point again. Let's just do 11036. Okay, so we're ignoring that decimal point there, and we're going to multiply that by 12. Okay. 2 times 6 is 12. 2 times 3 plus 1 is 7. 2 times 0 is 0. 2 times 1 is 2. And another 2 times 1 is 2. So we've done the 2. Now we move on to the 1, which is in the tens column, so we can put a 0 over here. 1 times 6 is 6. 1 times 3 is 3. 1 times 0 is 0. 1 times 1 is 1. And another 1 times 1 is still 1. So we want to add these together. 2 plus 0, we get 2. 7 plus 6 is 13. 0 plus 3 is 3, plus the 1 is 4. 2 plus 0 is 2. 2 plus 1 is 3. And bring down the 1. Right, so if you remember, we had 1 decimal place here, so we're going to put the decimal point back in. So we put it back in for the answer as well. So that means that what we've got, if we count 1, 2, 3 for our comma, we've got 13,243.2, and because it's money, It's going to be 20p. You could have multiplied in a different order if you wanted to work this out for 12 months. You could multiply this by 12 first and then multiply by 40. You should still get the same answer. Okay, 1D. Jessie needs to work out how much bonus she will pay each of her workers for the last month. She uses this formula to work out the bonus payment. And we've got B equals 0.015t, all divided by n. Now remember that when we've got a number next to a letter, there's like an invisible multiply sign there. Okay, you're multiplying them together. Where B equals the bonus payment per worker, so that's what we're working out. T is the total sales, N is the number of workers. Last month, the total sales were £38,000. Jessie had 3 workers. Work out the bonus payment each worker will get. Well, let's start this up here. So we're working out B. So we've got the 0.015, and we said that's multiply in the total sales of 38,000. And when we've got that, we're going to divide it all by 3. Okay, so what we can do with this, well, if we think just about the top for now, so 0.015 times 38,000. Okay, well, when we're dividing, you're probably quite comfortable with cancelling zeros. What we can do here is if we're multiplying by a 0, or like a 10, well, what this is doing, every time we multiply by 0, we're moving one of these decimal points across. So we can cancel that and move that over. Cancel another 0, move it over again, cancel that one and move the decimal point to there. So in other words, what we're saying is it's the same as 15 times 38. Okay. So we've got 15 times 38, and then it's all divided by 3. So we could multiply this out and then divide by 3, but what you might notice is actually on here, I can think of this, instead of 15 times 38 divided by 3, I can split it and say, well, that's the same as 15 divided by 3, then times the 38. Okay, because with bid maths, I know you're thinking we do division before multiplication, but it's not going to make a difference to this, because we've got the multiplication and the division. If we do the multiplication before the division, it's still fine. Well, 15 divided by 3, I know that 3 goes into 15, 3, 6, 9, 12, 15, so that's 5 times. So in other words, we're saying that's the same as 5 times 38. Now, that's going to be much easier to work out. 5 times 8, 8, 16, 24, 32, 40. And 3 times 5, 5, 10, 15. Add the 4, 19. Okay, so we've got a total of 190, which is what the bonus payment is going to be. Okay. So let's say if you're not totally comfortable with this cancelling here, then just multiply these out and then divide by the 3. The key thing you really want to get is the fact that when we've got the zeros at the end, we can use those to cancel or to move the decimal point over 3 times to get it into something a lot more manageable. Okay. Then we've got part E. There you go, we can fit it all on. Right. Jessie writes a report about the number of shoppers at the shopping centre. She writes, last week we were only open for 6 days because of a bank holiday. The mean number of shoppers was 21,000 a day and the range was 19.5 thousand shoppers. Jessie has this information about this week. we've got on Monday we had 15.4 thousand shoppers, Tuesday it was 12.5, and so on. Okay. Compare this week and last week using the means and the ranges. Okay, well we've got the mean and range for last week. We want the mean and range for this week. Okay, well, if we want the what should we do first? Okay, well let's work out the mean. Well, the mean is the total divided by how many? Or the frequency. So we want to add these all up. Okay. So 4 plus 5 is 9, plus 3 is 12, plus 8 is 20, plus 2 is 22, plus 6 is 28, plus 6 is 34. So 4, carry the 3, and bring the decimal point down. 5 plus 2 is 7, plus 7 is 14, plus 9 is 23, plus 6 is 29, plus 9 is 38, plus 1 is 39, plus 3 is 42. So 2 and carry the 4. 1 and 1 is 2, plus 1 is 3, plus 1 is 4, plus 2 is 6, plus 3 is 9, plus 3 is 12, plus 4 is 16. Okay, so we've got a total of 162.4. And how many have we got? Well, 1, 2, 3, 4, 5, 6, 7 days. So what we'll do is we'll do this using the Buster method. Okay, so how many times does 7 go into 1? Well, 7 can't go into 1. So what about 7 into 16? Well, 7, 14, that's twice. And 15, 16, that's 2 left over. So how many times does 7 go into 22? Well, 7, 14, 21. So that's 3 times with 1 left over. Carry that there. Keep our decimal point in line. How many times does 7 go into 14? 7, 14. That's twice. Okay, so we've got a mean of 23.2. Now we need the range as well. Well, the range is the biggest minus the smallest. What's the biggest value we got here? Well, it looks like it's a 39.6. And what's the smallest? 15, 12.5, I think. Nothing smaller than that. Okay, so in fact, let's just do it over here where we've got some space. 39.6 minus 12.5. 6 minus 5 is 1. Bring down the decimal point. 9 minus 2 is 7. 3 minus 1 is 2. Okay, so we've got our values. Now, they've asked us to compare this week and last week using the means and the ranges. Okay, so we can say last week. So what have we got last week? In fact, what's quite nice to do is if we think of last this and do a little table for us, okay? So we've got the mean and we've got the range. Then we can see all the information together, okay? So, in fact, let's just move back up here. Last week, the mean number of shoppers was 21,000. And the range was 19.5 thousand. Okay, so that 19,500. And this week, we worked out that the mean was 23.2 or 23,200. So what we're doing is we're multiplying that by 1,000. So we're moving the decimal point 3 times. So if you think 1, 2, 3, so we're going to get 23,200. And the range, well, we worked that out as 27.1, which is going to be 27,100. So we're just showing we've got everything nice and easy. And well, last week the mean has increased and the range has increased. So we can say last week had a smaller mean and smaller range. It's sometimes good to say about, when we're talking about range, rather than saying it's just smaller, we can also say last week the number of shoppers was more consistent. Yeah, so smaller range means it's more consistent, so there's less of a change in the numbers. And that's the end of the non-calculator section. And now for the calculator section. Question 2. Cameron wants to reduce the amount of water he uses at home. He uses the kitchen tap for 350 days a year for 20 minutes each day. The flow rate of his kitchen tap is 5.5 litres per minute. Cameron wants a new kitchen tap with a flow rate of 4.7 litres per minute. He thinks he can save more than 6,000 litres of water in a year if he uses the new kitchen tap for 350 days a year for 20 minutes each day. Is Cameron correct? Okay, so we've got an old tap, we've got a new tap. We're trying to compare how much water they use. So let's move this up so we've got a bit of space. Okay, so let's start off by thinking about the old tap. Okay, well, the old tap, we're using it for 350 days a year, and we're using it for 20 minutes a day. Okay, so this would tell us how many minutes we're using in total. And in each of those minutes, the flow rate, so the amount of water coming out of the tap, is 5.5 litres. So if we multiply this all together, what we're getting is, say, the 350 times 20 tells us how many minutes we're going to be using in a whole year. If we multiply it by 5.5, we're going to get the total number of litres used or coming out of the tap in 1 year. Okay, so we've got 350 times 20 times 5.5. So we've got 38,500, and that's litres. Okay. Now, for the new tap, what's this one? So this one, it's still 350 days a year, still 20 minutes a day, but the new flow rate is 4.7 litres. So in other words, it lets out a bit less water each minute, so that hopefully you save water overall. So if we look at this one now, 350 times 20 times 4.7, in 1 year with the new tap, it's going to use 32,900 litres. Okay, well, Cameron thinks he can save more than 6,000 litres of water in a year. So what we want to do is we want to find the difference. So we want to take away the smaller one from the bigger one. So in fact, I can put the 32,900 in my memory, and then we'll do 38,500 minus memory recall, 5,600. Well, that's less than 6,000. So is Cameron correct? No. Incorrect. So still a good saving, but not 6,000 litres. Okay. 2b. The diagram shows Cameron's bathtub. The bathtub is a prism with a cross-section in the shape of a trapezium. So if you remember, a prism is basically a 3D shape where the cross section, so the shape sort of at one end is the same all the way through the shape. Okay, and this cross section, so this end is a trapezium, so it's a trapezium all the way through. Okay, and we've got our measurements on here, all of them in millimeters. Let's move this up. That's it. Okay, and we're told that Camrell uses this formula to calculate the capacity of the prism. So again, let's move it up so we can see the full formula. C equals 0.5H, A plus B in brackets, and L. And if you remember, whenever we've got a number next to a letter or next to brackets, basically this means that we're multiplying. So it basically means 0.5 times H times whatever A plus B is times L. Okay, we don't need to put the times in, but sometimes it's good to write it out like this so you remind yourself what you're doing. So C is the capacity of the prism, so you're working out how much you can fit in it. A is the width of the bottom edge of the prism, so that would be down here. B is the width of the top edge of the trapezium, that would be up here, which would be the same as this one. H is the height of the prism, so that's the vertical height, not the sloping height, but vertical height. And L is the length of the prism, so that's going to be along here. Okay, so let's see what the actual question is. So Camrell normally fills the bathtub with water to 78% of its capacity. He thinks that if he fills the bathtub to 72% of its capacity, he will save more than 40 litres of water. Is Camrell correct? So it's a similar one where we're going to do some comparisons. So first of all, we need to find out how much water we can fit in the bath. Then we want to know what 78% of it is. We also want to know what 72% of it is so that we can work out what the difference is. In fact, we might have a little shortcut on this, but I'll show you what that is later on. So the first thing we want to do is to work out the capacity of the bathtub, and we can do that by using our formula up here. So we'll write it out again. So C equals 0.5 times, well, instead of H, we can put the height of the prism. So we can put this 600 in there. Okay. And then what we can do, well, in fact, one thing I'm thinking with this is if we're looking at the capacity, we don't have to keep it all in millimetres. In fact, what might make life easier for us is maybe if we turn these into centimetres. Okay, and the reason for doing that is that it's just going to be easier to work with slightly smaller numbers, but also there's a handy little formula. So we often talk about volume and capacity almost interchangeably, but they're slightly different things. So volume is talking about the actual size, the space inside, and capacity is talking about the amount of liquid or stuff you can fit in. So when we're dealing with volume, we work with usually millimeters or centimeters or meters, and when we're working with capacity, we would work with liters. Right, so the reason I'm saying all of that is because I know that 1,000 centimeters cubed equals 1 litre. Now, in some other exam boards, they tell us this. Now, they've not given us this bit of information, so you're just expected to know that. Okay. Now, the reason I'm saying this is we're going to need this to get from centimeters cubed to litres, but we're in millimeters. So the first thing I'm going to do is convert all of our measurements into centimeters. Now, there's 10 millimeters in 1 centimetre. So if we want to turn these into centimetres, we're basically just going to divide by 10 or take a 0 off. So that's going to be 60 centimetres. That's going to be 80 centimetres. This will be 180 centimetres. And this will be centimetres. So this is why it's good to read the whole question, work out what it is you're doing, and hopefully when you see litres, you think, oh right, so what measurements do I want for my sort of volume before I convert it over? So we've got all of those. So instead of 600, we're saying we're just going to make that 60 because we're doing it in centimetres. Now, what do we want? Right, now we multiply this by A plus B. Well, we said A is the width of the bottom edge, so that's 70. And B is the top edge, which is up here, which is the same as this one along there. And then we're multiplying that by the length of the prism, which is 180 centimetres. Okay, before we work this out, I'm going to do an extra step. So I'm going to work out the brackets. So I'm keeping the 0.5 times 60 times, well, 70 plus 80. Let's work this out. We've got 150. And we've still got the 180 at the end. Okay, so now we can put all of this in the calculator. Okay, so I know you couldn't see that while I was talking, but hopefully you can see what we've done now. So we've got 0.5 times 60 times 150 times 180, and all of that all together gives us 810,000. That's going to be centimetres cubed. Okay. Right. So this is where we then want to use our conversion and say, well, if that's centimetres cubed, to turn it into litres, we're going to need to divide it by 1,000. Or in other words, take off 3 zeros, and we're going to get 810 litres. Okay. Right. Now for the next bit. Well, if you remember, the question was telling us that he normally fills the bathtub with water to 78% capacity, and he thinks if he fills it to 72% capacity, he will save more than 40 litres of water. So what we can do is we can work out 78% of this and 72% of this and take away the difference. Okay, or take away to find the difference. But if you think, well, what we want, we actually just want that difference. So if he usually does 78% and we want to go down to 72%, actually, all we're interested in is 6%. So I'm going to do a shortcut and say, well, in that case, all I want to do is work out 6% of 810. So I can say 6 out of 100 times 810. So you can do it the other way and you'll see you get the same answer. This is just a bit of a shortcut. So that was my 810,000. We're going to divide it by 1,000 to get it into our litres. Then multiply it by 6. Divide it by 100. And we get 48.6 litres. Now, he thought that he would save more than 40 litres of water. 48.6 is more than 40, so yes, he's correct. Okay. The real tricky bit on this is recognising that we're going to need to convert the millimetres into centimetres, get our centimetres cubed, and then convert that into litres. So there is a lot going on in this question, which is why it's worth 5 marks. Okay. 2C. Cameron wants to wash his car. He knows it takes 120 litres of water to wash a car in a car wash. Cameron decides to hand wash his car. He fills up a 3-gallon bucket 6 times to wash his car. What percentage of 120 litres does Cameron save? This time they've given us a conversion that 1 gallon equals 4.55 litres. Right, so how much is he using to wash a car if he does it by hand? So we've got 3-gallon buckets, so 3, and he's filling it up 6 times. You can use your calculator, but hopefully you can do this one in your head. So we've got 18 gallons of water. We want to get this into litres because we want to compare it to the 120 litres. So we're going to multiply that by 4.55. Because if 1 gallon is 4.55 litres, 18 gallons would be 18 times 4.55. So we'll do the 18 times 4.55. So now we've got this in litres. Right. We're looking at what percentage of the 120 litres does he save? Well, we need to know how much he saves, so it's going to be 120 minus the 81.9. So again, I'm going to put that in my memory. I've cleared my memory from before. Okay, so now we can do 120 minus memory recall. Gives us 38.1 litres saved. Okay, but they want to know it as a percentage. Well, it's 38.1. It's out of 120 because that was the original amount. And then to turn it into a percentage, we're going to multiply it by 100. So 38.1, divide that by 120, multiply it by 100, and we've got 31.75, and that's now percent. Okay. 2D. Cameron looks at his quarterly water bill. And it says the total volume of water used this quarter is 118 metres cubed. This is 23% less than the same quarter last year. Work out the volume of water Cameron used for the same quarter last year. Give your answer to one decimal place. Okay, so this is 23% less than last year. So last year, you can think of that as the original amount. That would have been 100%. If we're using 23% less this year, in other words, 100 minus 23, that means that this year we're using 77% of the original. Okay, so the 118 metres cubed represents 77%. So we want to know how much you used last year. So, well, if this is 77%, the first thing we can say is 118. If we divide it by 77%, or 77, it's going to tell us how much we use for 1%. If we then want to find out what 100% is, we then multiply it by 100. So we're going to do 118 divided by 77 multiplied by 100, and we get up to 153 point. I'll write all the decimal places down for now, but we want it to one decimal place. Well, that's the one decimal place, so we look at the digit after it. It's less than 5, so we can just leave it as it is. So it's going to be 153.2, and it's meters cubed. Okay. Now what you might try to do is say, oh, okay, well, let's work out what 23% of this is and take it off. And you'll get a similar number to this. Sorry, you'll work out what 23% is and then add it on. And you'll get a similar number to this, but it won't be exactly the same. It won't be correct. And the reason is because this isn't 100%. So working out 23% of this doesn't make sense. The 23 they're talking about is the 23 of the original amount, which we don't know. So that's why we have to use the fact that this is 77% and then work backwards from there. Okay. Question 2E. The water company needs to reduce water leakage. This data shows the volumes of water leaked in 2019. Okay, so we've got water leaked in millions of litres per day and the number of days that we had this amount of this level of leak. So there were 87 days where between nothing and 200 million litres of water were leaked, There are 105 days where between 200 million and 400 million litres of water were leaked, and so on. And we've got 365 days in total because it was for the whole year. Use the data to work out an estimate of the mean amount of water leaked per day. Give your answer to the nearest whole number. Okay, so the estimate here, what this is telling us to do is we're going to have to do something with these ranges. Because for 87 days, it could have been that for all 87 days, nothing was leaked. Or it could have been for 87 days, 200 million litres of water were leaked. Or all in between, somewhere, anywhere in this range. So what we do is we'll say, well, we're just going to have to make an assumption. And the assumption is going to be, well, let's assume that for all of those days, it was smack bang in the middle. Okay, because we don't know any more information. So that's a reasonable assumption to make. So in the middle, we call that the midpoint. And the way we work out the middle is we add the bottom of the range, the 0, plus the 200, and we divide it by 2 to get halfway. So the midpoint is going to be 100. So for the next range, 200 plus 400, make sure we do equals first. Actually, on a simple calculator, it shouldn't matter. Then divide. Get 300. Okay. Or you can say, well, what's the number halfway between 400 and 600? So you might be able to just see, oh, well, that's going to be 500. But there's nothing wrong if you want to use your calculator to double check. 700. Okay. Right, well, the reason we're doing this is because we want the mean. And if you remember, the mean is the total divided by how much or how many. And we can call it the frequency. So that means that when we're talking about the total, it's the total amount of water leaked in the whole year. So the first thing we need to do is say, well, how much water was leaked in each of these periods? So like for 87 days. Well, if we're saying on average, or our midpoint is 100 million litres were leaked in a day, if there's 87 days, we're going to need to do 87 times 100, which is going to give us, and we can call this, what should we call it? Midpoint times days. Okay. So we're going to have 8,700. And we're going to do this for all of them, and it will tell us how much water was leaked for each of these ranges. Okay, so we're going to have 105 times 300, 31,500, and then 153 times 500, we've got 76,500, and then 20 times 700, 14,000. So if we're after the total, we want the total amount of water leaked, we're going to need to add these all together. I've already got the 14,000, so I'm going to go up backwards. And the 76,500, and the 31,500, and finally the 8,700. And we get 130,700. So that's our total. The frequencies are how many? Well, it's how many days. We've got 365 days. So if we divide that by 365, we get 358.08219. Again, I'm writing out all of the values there, but it said, give your answer to the nearest whole number. Well, these are the whole numbers here. We look at the digit afterwards. Well, that's less than 5, so we're just going to keep it as 358 days. Okay. 3A. Pavel organises a music festival. He puts this information on the festival's website. 4,908,630 people attended our festival over the last 30 years. Write 4,908,630 as a number. Okay, so this is where I find the commas really helpful. So we do everything to the left of the comma first. So 4 million. So we've just got 4. And instead of million, we put a comma. Then we've got 908,000. But if we do the 908, then instead of 1,000, put a comma. Then we've got 630. 630. There we go. Okay. 3b. Pavel has this scale drawing of the festival area. It is made up of a trapezium and a semicircle. So this is our trapezium. Normally we'd expect the trapezium the other way around, but these are our parallel sides, and a semicircle. Okay, and we've got the measurements on there in centimetres, and importantly, we've got our scale. And it says he needs to order fencing to go around the festival area. So this is going to be around the outside. So although they put this line here, this is just because they're telling us the distance, but we don't need the fence here. Fence is just around the outside. He will leave gaps totaling 65 metres for the gates. So we don't know the gate, it could be one big gate, it could be a gate here, a gate there, but in total it's 65 metres. And fencing comes in rolls, comes in rolls 50 metres in length. Okay. Right, let's look at the actual question. How many rolls does Pavel need for the... Oh, you can't see it. How many rolls does Pavel need for the festival area? We're told to use pi equals 3.14. And we got 5 marks for this, so we know it's going to be a big question. Okay. Right, so... basically, we need to add up all of these distances. And we've got our scale as well to think about, but we can... probably depends when we want to use the scale. We can work out the scale now, or we can and do it for each measurement, or we can do it at the end. I'm thinking maybe we do it at the end. Might be nice. So let's see if we do that. We'll stay working. Normally I'd say to convert as soon as possible, but I'm thinking we might be nicer not converting, because then we can deal with smaller numbers. So let's have a go with that. So the perimeter is going to be this length plus this length plus this length plus this length. So this is the tricky one for now. We don't know how long that is. But what we do know is that if you imagine this is like, it's a semicircle. So we've actually got like the rest of a circle going round, something like that. And I know that there's the circumference of a circle, so the perimeter of a circle is, well, you can think of it as 2 pi r, or you can think of it as pi d. Basically 2r, 2 times the radius, is the same as diameter. So whichever one you want to use. Now for this, because we know the diameter, it's probably easier to use this version of it. Okay, so pi d, so we're told to use 3.14 for pi, and d, the diameter, is 6. Okay, so get our calculator, 3.14 times 6. So we've got the circumference is 18.84 centimetres. Now we don't want the full circumference, because that would be the whole circle. We want half a circle for a semicircle, so we're going to divide that by 2. And we get 9.42 centimetres. So now if we want to work out the perimeter, well, we can say it's the 9.42 plus the 7 plus the 4.5 and plus this 7 down here. Okay. And we get a total perimeter of 27.92. Now that's still in centimetres. Okay, now we need to do our conversion. So we want to turn this, we know that 1 on here, so 1 centimetre on here would be 20,000 centimetres in real life. So if we do 27.92 times 20,000, that's going to be quite a lot. 558,400. That's still in centimetres. Okay. Now, we know that there's 100 centimetres in a metre, and we know that there's 50 metres on our rolls on each length of fencing. So we want to get into metres. Okay, so if there's 100 centimetres in a metre, we need to divide this by 100. So divide it by 100, and we've got 5,584 metres. Okay. Now, we want to think, this is our metres, but we know that we've got to have some gaps here. So we can take away the 65 from here, because we don't need fencing where we've got the gaps. So that means we need 5,519 metres of fencing. This is where it helps to put a couple of words just so you know, to remind yourself what it is you've actually worked out. Okay. Now we've got 50 metres on a roll. So how many 50 metre rolls are we going to need for this? Well, we're going to do 5,519, that is a 5 by the way, and divide it by 50. And that gives us 110.38. But you can't buy 0.38 of a roll, so we're going to need 111 rolls. So if we have any less than that, we won't have enough. And that's the end of the question. So actually, I think it was the right thing to stay in centimetres on this because it kept our numbers nice and small. But if you did convert, first of all, you'd still get there. You'd just probably have a lot more zeros in your calculations. Okay, 3C. The main stage is a square-based pyramid. Pavel needs to work out the surface area of the 4 triangular faces of the pyramid. So this face here, this one here, and then the 2 at the back. He uses this formula. Let's move this up for us. And we've got the A equals 4, and then brackets, so it means 4 times BH, or B times H, divided by 2. And A is the surface area of the 4 triangular faces of the pyramid. So this is working out all 4 faces in one go. B is the length of the base of the triangular face, so along here. And H is the slant height of the triangular face. So normally we'd want the vertical height, but they're saying it's the slant height. So it's going to be, slant height. What do they mean by slant height? I think they just mean the fact that the triangle is leaning over. But if you imagine that this was a triangle, that would be the vertical height, which is what we'd normally want. Assuming it's referring to this. Yeah. Okay. And if you're not sure, we'll think, well, what else can I use? I haven't got any other numbers, so it must be talking about that length that way. Pavel thinks the total surface area of the 4 triangular faces of this pyramid is 1,200 metres squared. Is Pavel correct? Well, let's work it out for Pavel. So we've got the area is 4, so we're going to put times. We'll keep our brackets for now. BH. Well, B, we said it's the base, so it's going to be 40 times H, which is our 30 metres, and that's all divided by 2. So I'm just going to do this one step at a time. You might want to do some shortcuts, but that's fine. I'm going to keep it nice and simple. So we've still got 4 times. Now we can do the multiplication at the top. So the 40 times the 30, which gives us 1,200, divided by 2. We've still got our brackets. So again, I'm just doing one step at a time. So I'm going to work out the brackets first. So the 4 stays the same. The 1,200 divided by 2 now becomes 6. And 4 times 600 gives us 2,400 metres squared. Pavel thinks the total surface area of the 4 triangular faces of this pyramid is 1,200. Well, 1,200 is less than 2,400. So is Pavel correct? No, he's not. Okay, 3D. The coordinate grid shows the space for the car park. Okay, so we've got this here. So going up to 15 across and that 15 up. And we've got two points and a line joining the points. We're told the car park is rectangular. It measures 120 metres by 100 metres. Each square on the grid represents 20 metres by 20 metres. So let's just show what we mean by that. So it's saying that's 20 metres. That's 20 metres. Pavel draws two vertices and one edge of the car park. Well, a vertice or a vertex, which is one vertice, is just a point. So he's drawn 2 points on here and one edge of the car park. So joined them together. Write down possible coordinates for the other 2 vertices of the car park. Okay, so let's have a look. We've got 1, 2, 3, 4, 5, 6 squares there. And we know that each one is 20 metres. So 6 times 20, or 6 times 2 is 12, add the 0. So this must be the 120 metre side. Okay, so we've got to work out where the other corners could be. Well, if that's the 120 metre side, we need to use a 100 metre bit. And if it's 100 metres, if each square is 20, we can do 100 divided by 20, which means we must have 5 squares going the other way. So it's up to you. You could go up 5 this way and have your car park up there, or just because it fits on my page nicer, I'm going to go 1, 2, 3, 4, 5, have one corner there, and 1, 2, 3, 4, 5, and have my corner there. Okay. It hasn't asked us to draw the car park in full, so I don't need to connect the points. You can if you want to, it doesn't matter. But what it wants is possible coordinates for the other 2. So it's the coordinates of these. Well, the x coordinate, so a cross always comes first, going to be 4, and the y coordinate is 2. And for this one, it's going to be 10, and also 2. Okay. So you could have different coordinates if you went up instead of down. Both of them would be absolutely fine. Okay. 3E. The area where the festival goers will have their tents is 314 acres. Pavel knows that for safety reasons, each tent requires 27 metres squared. He thinks that more than 50,000 tents can fit into this area. Is he correct? Show how you decide and use the conversion 1 acre equals 4,046 metres squared. Right, well, I don't like having metres squared and acres, so the first thing I'm going to do is I'm going to turn these acres into metres squared. So if 1 acre is 4,046 metres squared, 314 acres is going to be 314 times 4,046. Which gives us 1,270,444 metres squared. Right, that's the total space we've got. Each tent needs 27 metres. So if we divide this by 27, it'll tell us how many tents we can fit in there. And we get 47,053.481. Well, you wouldn't be able to fit 0.481 of a tent, so we'll have to go down to the nearest whole number, which is 47,053. Well, that is less than 50,000 tents. So, no, he is incorrect. 3F. The probability that a festival goer chosen at random has travelled by car is 14 out of 25. What's the probability that they did not travel by car? Give your answer as a decimal. Well, 14 out of 25. So the other people must be whatever else we need to get from 14 up to 25. Or in other words, 25 minus 14. So we must have 11 out of 25. And you can think of it because the ones that do travel by car plus the ones that don't travel by car should equal 100% or 1. Okay, so that was good. Right, we want the answer as a decimal. We've got a calculator, so we could just do 11 divided by 25, which gives us 0.44. And now we can move on to the next question. So 4A. Mel is an apprentice in a college admissions office. She is organising interviews for new applicants. The ratio of interviewers to applicants each day should be no higher than 2 to 15. There were 5 interviewers available on Monday. What's the maximum number of applicants Mel should invite on Monday? Right, it's a ratio question, so we're going to draw a table. And we're going to have interviewees or interviewers and applicants. And we don't want the ratio to be any more than 2 to 15. In fact, we've got 5 interviewers. So what we want to know is how are we getting from 2 up to 5? And the way we do that is we do the opposite. We say 5 divided by 2. And if we do that, we get 2.5. So what we're saying is we're multiplying by 2.5 to get from 2 to the 5. So we can do the same over here. So 2.5 times 15 gives us 37.5. Now this is the maximum. You can't have 0.5 of an applicant. And if we went up to 38, it would be going above the answer. So it must be 37 applicants. Okay, 4B. All applicants who attend the interview complete an initial assessment. Mel has this scatter diagram about the results of the initial assessment. Okay, so we've got the title, Initial Assessment Marks and Age of Applicants. So let's have it here. So this is their initial assessment mark and this is their age. So we can see for, let's pick a nice one. This person here, so for this was a 16-year-old. You can see we're going up in 2s each time, so that would be 16-year-old. And their mark was here, we're going up in 2s. So they got a mark of 32. Okay. We can pick another one. This person here. So 2, 4, 6. So this was a 36-year-old. And their mark was 22, 24. And they got a mark of 24. So this is showing all the different results that they got. And the question is, what fraction of applicants over the age of 26, so that's important, scored more than 40 marks? Okay, so the first thing is that we're only interested in the ones over the age of 26. Well, as we said, we're going up in 2s here, 22, 24, 26, 28, 30. So what I can do is I can draw a line straight up at 26. Because we're only interested in the ones over, so we don't care about any of these people. Okay. Now, of the ones over the age of 26, we want to know the ones that scored more than 40 marks. Well, so 40 marks would be here. Okay, I've sort of done it like that because they got 40. So if we want more than 40, this one would count as not more than 40 because it's exactly 40. So, yeah. What fraction of applicants over the age of 26 scored more than 40? So to do it as a fraction, first thing we need to know is how many people are over the age of 26. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's going to be our denominator. How many applicants scored more than 40? So again, we're not going to count that one. We want 1, 2, 3, 4, 5. So the fraction's going to be 5 out of 12. 4C. Mel has information about applicants accepted on 2 new courses. So on course A, there were 22 male applicants and 59 female applicants. And course B, we had 71 male applicants and 48 female applicants. What's the probability one of these applicants chosen at random is female and accepted on course B? So female and on course B, so it's 48. Okay, so what we want is the 48 out of the total number of applicants. So the way we can do that is, well, let's work out the total on course A first of all. So 22 plus 59. So we've got 81 on that course and 71 plus 48, 119 on this course. So that means that the total on both courses is going to be the 119 plus the 81, which is 200. So we've got 48 out of 200. We want it as a percentage, so we multiply it by 100. So 48 divided by 200 times 100. No? Yes. It equals 24%. Okay, 4D. Mel needs to write a report about the income from tuition fees. She has this information about tuition fees. So course A costs £390, B costs £650, and so on. Mel writes in her report, the college has a 1.7 million income target this year. If 1,476 students enrol onto courses and pay the modal tuition fee, the college will achieve more than 5/8 of this target. Is this statement correct? Right, lots of things going on, so we've got to split this down into smaller questions. Right, so the first thing we need to work with is we're interested in the modal tuition fee. Okay, so the modal, or the mode, is the one that occurs most often. Okay, so let's have a look at our different fees. So I'll do a little table. We've got fee and we've got frequency. So £390. How many times is that the cost of a course? So we've got 1, 2, so twice. What about £650? There's one course at that price, only one. £720? Got 1, 2, 3. £460? Got 1, just once. I'll extend this down. And £980? 1, 2. So the modal, the one that occurs the most, is the £720 fee. That is our modal fee. That's the most popular or most common fee for a course. Okay, so we've worked that out. If 1,476 students enrol onto courses and pay the modal fee, so what we need to do is 1,476 times 720. That's going to tell us how much money they make, or what the income is. So 1,476 times 720. So we've got 1,062,720. Okay, now this says the college, if this number of students enroll, the college will achieve more than 5/8 of this target. Well, so this is how much they actually got. What is 5/8 of the target? So we want 5/8 of, which means times, 1.7 million, which is going to be 1,700,000. Okay, so 5 divided by 8 times 1,700,000. And we get, I'm going to write it underneath because it's a very similar number, 1,062,500. So very close. It will achieve more. Well, yes, that is slightly more than this. Not a lot, but £220 more. So is the statement correct? Yes. It's correct. E. The conversion rate is the proportion of all applicants who go on to enrol on a course. This proportion is expressed as a decimal. Mel needs to compare the conversion rates for this year and last year. Mel has this information about enrolments this year. So there were 7,680 applicants, and the applicants who enrolled on a course were 4,167. Last year, 6 out of every 11 applicants enrolled on a course. Is the conversion rate this year lower than the conversion rate last year? Show how you decide. Right, well, we want it as a decimal, so what should we do first? Let's do this year first, because those are the numbers that have come first. So it's 4,167 out of 7,680. We get 0.54. I'm going to do it to 3 decimal places, so 542, but this is 5 or more, so we're going to round it up to 543. Now for last year, 6 out of 11. So it doesn't matter that we haven't got the total number of applicants. We've got this as a ratio. So 6 out of 11. This is going to give us a decimal. 0.5. Well, 1, 2, 3 decimal places. This is less than 5, so we're just going to keep it as 0.545. So this year is less than last year. What they're asking is a conversion rate this year lower than last year. Yes, this year is slightly lower than last year. So yes, I can leave it like that. And finally, 4F. A new student takes out a student loan of £1,450 for 2 years at a compound rate of 3% per annum. Work out the amount of interest owed on this loan after 2 years. Right. So, best way to do this is, well, you can use, there's a formula you can use for this, but I don't think you need to necessarily remember that formula, because what we can say is, well, we've got £1,450, we're getting interest at a rate of 3%. So what we want to work out is not just the amount of interest, but we want to work out what the total value is going to increase by. So we're going to multiply it by 1.03, because this is like 1 is like the original 100%, and 3 is the 3% interest. Now, because it's for 2 years, this will give us the amount, including interest at the end of the first year. If we multiply it by 1.03 again, we're going to get the amount at the end of 2 years. Okay, so let's see what we get. 1,450 times 1.03 times 1.03. So the total amount, 1,538, and it's money. So we want 2 decimal places, 30. But this is 5, so 5 or more we round up. So it's going to be 31. So the total amount, including interest, is going to be £1,538.31. They won't work out just the amount of interest, so we need to take off the original amount, which was the 1,450. And if we do that, we get £88.3. Again, the 5s we round up, it's £88.31p. And we can put that down here. Okay. What you could do if you don't like doing putting the 100% and the 3% together, you could work out 3% of this, add it on, and then work out another 3% of that new total. That'll give you £88.31. Doesn't matter which way you do it, but I think it's good practice to start doing the 1.03 when you're trying to increase the amount, because especially if you've got more than 2 years, if you're looking at 4 or 5 years, then it becomes quite time consuming to do it the other way. So that's the end of the paper. So I hope you found it helpful. Please like the video, subscribe to the channel, and look forward to seeing you again soon. Thank you.